Studies Section 8 Formal Argument in Artificial Language Introduction. In this study section, we will specifically examine the nature of words and phrases that we use in forming compound statements. These words and phrases are called logical connectives. Also, we will observe the logical symbols representing the various connectives. Learning outcomes. When you have studied this session, you should be able to discuss the meaning of logical connectives. Highlight the logical symbols that represent connectives. Logical connectives or logical constants. In logic, we can identify two kinds of statements. On the one hand, we have simple or atomic statements. A statement is simple if it has no other statement as part of its component. For example, the statement "it is raining" is a simple statement. On the other hand, we have compound or molecular statements. A compound statement is made up of at least two other statements. An example of a compound statement is either "it is raining" or "the ground is wet." Compound or molecular propositions are formed by using what we call logical constants or connectives, and there are 5 of such connectives. Forms of connectives. Conjunction. A conjunction consists of two propositions joined by words like "and," "but," "though," and their equivalents. The two parts of a conjunction are called conjuncts. The logical symbol that represents all forms of conjunctions is the dot sign. The expression "Peter is in Lagos and John is in Kaduna" is a conjunction. Now, if we represent the statement "Peter is in Lagos and John is in Kaduna" as P and J, then the conjunction of both statements will be symbolized as P and J, which means P dot J. The conditions under which expressions involving a conjunction can be true or false can be expressed using the following table. P table. True, true, false, false. Dot table, which is "and." True, false, false, false. J table. True, false, true, false. The above table reveals that a conjunction is true only when both conjuncts are true and false when at least one of the conjuncts is false. Disjunction. A disjunction is a compound proposition in which two statements are joined by the connective or its equivalent. The two parts of a disjunction are called disjuncts, and the logical symbol that represents the disjunction is the wedge, which is the symbol V. The expression "Peter is in Lagos" or "John is in Kaduna" is a disjunction and is symbolized as P or J. The truth conditions for a disjunction can be expressed as follows. P table. True, true, false, false. V, which is the symbol for "or." True, 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 false. J table. True, false, true, false. From the above table, a disjunction is true when at least one of the disjunction is true. A disjunction is only false when both disjuncts are false. Conditional. A conditional consists of two propositions joined by the connective if, then, or its equivalent. The statement on the left-hand side of the conditional, that is, the statement between the if and the then, is called the antecedent. The statement on the right-hand side of the conditional, that is, the statement following the then, is called the consequent. The logical symbol that represents the conditional is the horseshoe sign. That is C in the opposite side. When you write C in the opposite side. The expression, if Peter is in Lagos, then John is in Kaduna, is a conditional statement and is symbolized as P, then J. The truth condition of a conditional can be represented in the following table. P table. True, true, false, false. Then table. That is C, that is written in the opposite side. True, false, true, true. Q, true, false, true, false. The above table reveals that a conditional statement is only true when the antecedent is true and the consequent is false. Biconditional. When two propositions are joined by the connective if and only if, then the expression is called a biconditional. The two parts of a conditional are called components, and the logical sign that represents the biconditional is the triple bar. The expression Peter is in Lagos if and only if John is in Kaduna is a biconditional statement and is symbolized as P if and only if J. The conditions under which expressions involving a biconditional can be true or false as shown below. P, true, true, false, false. Then, that's the triple line. True, false, false, true. J, true, false, true, false. The above table reveals that a biconditional statement is true either if both components are true or if both components are false. A biconditional is false if both components have different truth values. Negation. If someone says it is raining and another person says it is not raining, the second person has negated what the first person said. A negation is a sentence which contains the negation sign not or its equivalent. Ordinarily, a negation looks like a simple statement, but logically it has a compound structure. The logical sign that represents the negation is the call sign. When a statement is negated, the negation sign is placed immediately before the statement being negated. John is not in Kaduna is an example of a negation and is symbolized as not J. When a statement is negated, it takes on the opposite value. In other words, when a statement say P is true, not P will be false. And when not P is true, then P will be false. This is displayed in the table below. P, not P. True, false. False, true. Study session summary. In this study section, we examine the nature and truth conditions of words and phrases that we use in joining two or more simple statements to form compound statements. These words and phrases have been grouped into 5 categories of connectives. These are the conjunction, disjunction, conditional, biconditional, and negation. This is the end of study section 8. Thank you for listening.